This is a presentation on engineering design. The first thing I'm going to do is go through a little bit of a graphic that describes the engineering design process, and then I'm going to go through each step in a little bit of detail. So this is the graphic that I developed about engineering design, and it's important to understand that this is a simple version of it that looks quite linear. But what you do is you start with a problem, and then you go through the design, build, and test process, and then communicate the results. Within the design process, there's several steps that's often considered engineering design. And it's one of the things about this is that it looks pretty straightforward, but in practice, there's a lot of iteration going on. We might do a test and then see that we need to go back and redesign the specifications. We might build it and then see that something about that's not working, so we'll have to go and do some more engineering analysis. But what really happens also is that we definitely take all of these steps, and generally through this process, this straightforward process, we go through, and then but often we need to circle back around. So let's go ahead and look first at defining the problem. So this is a very important step, and it might seem like that it just is given to you, but for engineers, we really need to talk a lot about what happens in this particular step. So one of the methods that's pretty popular now is called design thinking, and also some entrepreneurial methods are also used in this particular part of the design process. So we might want to focus on empathy for the user. We might do extensive interviews to find out what's called pain points. Those are methods that used in this particular step. It's also super important to understand what needs to be done, not how it should be done. So it's a really common error for engineers often to say, oh, wow, I have this really cool technology. I want to find a solution for this technology. And that's a really important thing not to do as an engineer, to really interrogate what is the problem, what needs to be fixed, not how to fix it. So the next step in the process is background, looking at background. And we spend a lot of time here, especially in global development, when we really are at a big disadvantage to understand the culture. We just are not clear about the particular culture when we are doing global development. We have a white Western view of concerns, which is not always a universal global concern. So this is why it's really important to have some social sciences involved in this to help us understand the context, especially when we're doing development work. And even in the United States, if we're just doing problems within the US, it's so super important to understand the context. We also want to know, like, how has this particular problem been addressed in the past, something like competitors, understand the history, how we got to this place, and particular laws and policies. There's an endless amount of things that we need to do in this background step. Now, most experienced engineers would say that novice engineers will rush through this step, and that it's super important to spend your time and do complete analysis regarding the background of the problem. The next step we're going to look at is the idea of design specifications. So once we understand the problem and we understand the context and the background, what we want to do is actually convert all of that into something that's like performance criteria for the thing that we're designing. You can think about it like, the problem is I want to get from New York to San Francisco, and the performance criteria is I want to be able to do that within 10 hours, and I want to do it in a comfortable way where I'm not exhausted at the end. So anything related to quantitative or qualitative performance is very important to put into these design specifications. Now, one thing that's useful, there's a tool that's useful that I've used before called House of Quality, and it's a way of converting sort of user requirements into engineering design specs. And that's just a technique that could be used. And there's other that are maybe more discipline specific. The next step we're going to go to is looking at developing alternatives. So in this, it's a very creative process where we just do a lot of ideation and ideas generations. And we really need to be careful about not having our preconceived constraints in mind, that we're open. Brainstorming is sometimes used in this process where we ask questions like, well, what if we don't do anything? Is that an option? Is there other ways to address this problem that are sort of way outside the box? And it's often really, really helpful to have a diverse set of thinkers in this process, because you don't just want people who are all thinking the same. You want people with different experiences and different backgrounds that'll help you actually in this alternative generation process. And then from there, what we'll do is we'll actually do engineering analysis. So look at these alternatives, do some calculations, do math and science and data analysis related to alternatives to try to narrow it down into the specific alternatives we want to look at, and also to really understand the problem more. And that will also possibly generate other alternatives. And then once we get our alternatives, what we want to do is we need to evaluate these alternatives. And we're going to evaluate these alternatives compared to the design specifications that we have previously defined. So looking at, okay, does this particular alternative satisfy all of the design criteria? And if not, which ones? And are there trade-offs associated with some of those things? So there's other techniques that we might use here called trade analysis. There's a lot of disciplinary specific processes that are used throughout the engineering design process. And then the next thing we'll do is actually choose a design. So this means we need to decide and then specify what the design is. We're going to create drawings. We're going to put together specifics related to the design. And then once we do that, then we can move to the next step, which is the build process. So we might build a prototype, we might build a full scale, we might do a scale model, we might do a simulation. Again, that depends on the particular product and the discipline to see what's the most important thing to build. But the actual building of it, the prototyping of it, is super important. And then from there, the next thing we'll do after we have a particular design, we need to go through tests. And these tests are a real design of experiments. Like, we design something to meet the design criteria, but in what range does that happen? Does that always happen? Are we always going to be able to go this fast, or will it always be able to lift this much? And so we'll need to understand what are the limits of that. And that's why testing is very, very important. And then the last thing is communicating solutions. So in this step, we're going to be telling stories about our solution and persuading that we've done a good job in the design process. So that's like a pretty quick look through all of the steps of engineering design. Many engineering disciplines have variations on this, but most all of them map onto this engineering design process. And there's some methods that are going to be different or more detailed in some disciplines, but generally that is the steps that we're going to be using.